Hey guys, welcome to this video. In this project, we'll be completing an end-to-end data science project, and we'll be using machine learning, NLP, and Python, and many small steps to clean our data. So you can check out the whole code repository for this project in the description of this video. And this would be a cyberbullying project. So it will be basically a tweet sentiment classification where we'll classify each particular tweet into a particular category. And do check out my LinkedIn page also for similar updates, and also subscribe to Project Pro for more similar end-to-end project videos. Thank you.
Guys, this would be a three-part series. In the first part, we'll be covering the pre-processing, cleaning, and EDA of the project. In the second part, we'll be making a machine learning model to classify particular sentiment into different categories. And in the third part, we'll be deploying this model over Django. Right, so it will be a three-part, complete series, which will enable you to have one end-to-end project in your portfolio. So let's start with the first part. So in the first step, we have imported some of the libraries that would be useful. So I've classified this in four categories. So number one category is the libraries which will be used to play around dataset in pandas, right? So we have pandas, numpy, matplotlib, simple kind of charts and for those kind of things. So these are not any new libraries. For any data science project, you will be using these libraries. Secondly, we have libraries for specifically for NLTK, right? So we are fortunate enough to have this NLTK library. So all of your NLP needs will be satisfied by one NLTK library. So we have imported various modules. Stemming and lemmatization is one of them, and we have imported word cloud and some small modules as well, which will help us clean the data and tokenize it. Then we have used sklearn to import some of the modules that will be used for preparing your model, right? And then finally we have used sklearn only to import some of the models, right? So we'll be using regression and some of the ensemble models, and also SVM and naive Bayes, right? And in tree model we'll be only using decision tree, and I guess in ensemble we are using random forest. So that will be enough, and we'll see if anything more is needed, right? So let's say the first step, I'm just reading the data set. So I have this sorry, I have to run the first cell. Yeah, so once I run the first cell, it will get all the libraries that are required. Yeah, so luckily I have all of them imported. If you get a module error, some module not found, so you can just do a pip install, and you should have, I guess, Python and pip in your, if you have Python you have pip, right? So you can just do pip install and the module name which is is not available. So and you can just then get that module and again run the cell, and it will work, right? So then we have got our data. So this data is provided to us, and it's a cyberbullying tweet CSV, and it has one column of tweets, other column is of all the sentiments that are there, right? So let's see the info. So doing a df info, so that we can get okay, what two we have two columns and none of them has null values. It's a good thing for us, and it's in both our object type, so basically both are string type, right, as of now. So let's say we see a df head. So df head basically gives you the top 5 rows, right? So when I do a df head, I see, okay, there's a tweet text column and there's a cyberbullying type column, right? Let's also see one more thing. Let's also see df tail, right? So df tail will give you the last last 5 column, right? And you can also provide a particular number here to see number of column. Let's, for example, I don't want 5, I want 10 columns, so I will do df 10, so we will first 10 columns, right? So yeah, I see a tweet and I see a particular cyberbullying type, right? So okay, this particular thing is classified into this, right? So see guys, if you're fortunate enough to here have a labeled data set, if it's not there, people sometimes give feedback. So now you can understand where when you report a particular tweet, right? Key when you report it to a system, so this is how system label that particular tweet. Okay, and then it's used for building the model. And so we check number of null values. We already did it, so let's do it once more, right? And let's see number of categories of cyberbullying. So I see that data is quite evenly distributed. It's a good thing for us. We don't have any class imbalance kind of a thing, right? So almost all categories have a similar quantity of data, and we have to classify them accordingly. So it's basically a multi-class classification problem. Let's see. So first thing that I'm doing is I am renaming my column name. So because it's a tweet text and cyberbullying type, it's kind of makes sense, but they're a little bit complex. We are going to use them again and again, right? So let's make them a little simpler. So my first column is text, the other column is sentiment, right? So I've done a df.rename to do that, and then again check the head of it. So now the column names are changed, text and sentiment. And don't worry about the code, guys. I'll provide the whole code in the description. I'll provide my GitHub link in the description, and you can see the whole code from there. Just focus on the steps now, that what we are doing and why we are doing. And to be honest, it's really important for you to understand why we are doing all these steps, right? Because see, all these steps, if you are having problem in doing it, you will one or the other way figure out how to do it, or or you will find a better article to do those steps, right? But understanding the reason of doing it, that's the most important thing, right? Because these steps are taking, but why we are doing this, right? So let's go from that perspective, understanding the reason for each step. Okay, so now in the next step, what we have done, we have done the label encoding of it, right? So see what happens, that computer will not understand your text, right? So you have to provide it with numbers. So first thing that we do is that we provide numbers to all of these classifications, the classification classes, right? So what I did, I provided a particular label to each of them. So religion goes 1, age goes 2, ethnicity 3, gender 4, cyberbullying 5, and non-cyberbullying 6. And then again check my dataset. So now let's say, sorry, I need to run this one first. Yeah. And if I now do a df tail, so I see a sentiment encoded as 3, right? So here we have provided ethnicity equals to 3, so it goes sentiment equals to 3. Now I have done some NLTK download. So see what these things are. So when you import NLTK and you import stop words and some other inside libraries of NLTK, sometimes it does not give you the whole things that you need, right? So you need a particular package of NLTK text to classify, and that will be used in our steps, right? So actually when I was doing this, I was facing some errors. You don't have this NLTK word net or this bunk net, those kind of things. So this particular code will be given the error itself, that okay, what things are needed. You just have to run NLTK.download. You have already done an import NLTK above, right? So it's here, right? So you don't need to import it again. You just have to download some part of NLTK so that you can use it. Let me see where were we. Yeah, okay. Now here we have set some stop words. So what are stop words? Stop words are kind of words that are common words which are not useful in our algorithm, right? So as we talked earlier, that what NLTK is basically, the idea of NLP is that we are creating, if we are doing count vectorizer, TF-IDF vectorizer, we are finding a frequency of each word, and then we are feeding that frequency into the model, right? So there are some words which are not useful, and if you include them in your vectorizer or count vectorizer, so you'll just increase the complexity. So what you do, you kind of ignore some of the words, right? So those are called stop words. So these would be words like was, there, having, kind of, these kind of words, which those kind of words. So those kind of words we have taken a list of it. Okay, these are total words, and what we'll do ahead, what we'll filter our text of these words, right? We'll remove all the stop words. So first step, what we did, we removed this emojis, right? So we have imported a function of emoji, so it will remove, it will classify all the emojis, right? So we have just made a function, and later we'll run this function on our text, right? So we have just replaced all emoji with null, like not null values. Basically you're replacing it with nothing, right? So they will completely be removed from your text. Later we are removing all the entities, right? So we are removing all the URLs, the non-UTF stuff, numbers, and stop words, right? So you can see here that how we are removing it, right? So I'm just doing I have the this regex code. So I just it's a really useful code. You just have to find this thing, and it is replaced by this. So just see this line, you'll get understanding of code. So you have re.sub, right? So basically you're substituting, right? In this particular text, in the whole text word that is being passed as an argument, I am replacing anything bit like this pattern with a nothing, right? So basically it will be removed, right? And I'm doing it in text, which is argument. And I've also taken a lowercase of all the letters, so that similar kind of letter falls in the same category. We don't have different letters of one is lowercase, one is uppercase. Later I have taken a list of punctuation, and I have removed the punctuation as well. And finally I have done a for loop over all of my text, and if I have checked, okay, if the word is stop word, then remove it. If the word is not in stop word, then keep it. And then finally I have got written the text, right? Similarly, I have done a decontract, right? So here also I have removed the contractions that are there, right? So for example, if I write can't, right? So it will be can apostrophe s t, right? So that not makes sense. So I want to remove any word like that to cannot, right? So similarly, if I'm writing r, right? So for example, I'm writing ur. So when you write quickly, right? So it's like u apostrophe s re. So instead of that, I'm using complete r so that it will make more sense, right? And later I'm cleaning the hashtag because it's a tweet data, so obviously you'll have hashtags in it, right? So I want to remove the hashtag, but I don't want to remove the later part of a hashtag. So again, I used a regex for it, and I've removed the tweets. And yeah, later after that, I'm using one more function to create a special, like remove the special characters, right? So here you can see that I have made a for loop that checks for every word, and if the word has apostrophe s, like and or dollar sign in it, then we remove the word, and finally we remove each word and store the correct word in a series, and finally we make that particular list a sentence, right? And then I've removed multiple spaces, then I've done stemming and lemmatization, right? So as we discussed, stemming and lemmatization, these are two tokenization process, not tokenization process, sorry, these are two text cleaning process. There's a slight difference between both of them. So stemming and lemmatization is just, there's one major difference, is that stemming and like one of them gives you exact value, as we discussed. One of them give you the exact word, and the other word crops the word, but and the final word may or may not make sense, right? So that's the difference we have, like. And why we are making specific functions of it? So see, we have all of our data in a pandas data frame, and you want to utilize the pandas functionality, right? So there's a particular function in pandas called apply, right? So once we'll make this function, we'll apply all of these functions over our individual text, and that way we'll also utilize the pandas functionality, and we'll run the function as well, right? So I made all of these function into a bigger function, so that I have to just apply now one function, and will uh, apply all of this function one by one, and return me the text, right? So I have df clean text and text dot apply preprocess. Now preprocess is taking up individual text, and then is applying one by one all these functions that we have decided defined above: stemmer, lemmatization, remove multi spaces, filter charts, clean hashtags, decontract, strip all entities, and strip emojis, right? All of these functions are being called inside preprocess. Okay, now, oh sorry, I forgot to run the code. I need to run it again so that we can see the results also. Yeah, so we have taking the defining each functions. Yeah. Okay, so finally, once we apply all of these function to our DF, we'll have one column of clean text, which has done all of these pre-processing that we have defined above. Cut. Yes. So now when I run the text, right, so see, you might see some small errors. So and just follow a simple procedure to debug the error, right? So just go into a depth of error and see which point it's getting an error. Mostly it will be a kind of the kind of error I faced while doing it was, sometimes I because it's a complex string, right? If I see this particular part of a string or this particular part of a string, these all are complex strings, right? So at some point you might face problem in this might be a typo mostly, right? So these kind of error could be there. Other errors I'm not supposing, right? Because we have imported all the libraries, and these codes are just following a standard procedures, right? So I don't expect a bigger error here. Mostly it will be the error that you would be facing, it will be of module not found, or particular NLTK does not have that word, or you need to download a particular NLTK, just like I did here. So these solution would be given in the error itself, so you won't face any trouble. Okay, Later, once I've got my, you can see the column of clean text. So now words have been quite clean, but it will not make sense to us, right? Because we are we are used to read a whole sentence with stop words, right? For example, why is Ostip so wide, this kind of, it's not a cyberbullying tweet, right? So it has removed why is, right? Because those were stop words, right? Why is does not, see, the point is that why is does not make sense in any sentiment, right? It's the individual words and a pattern around those words which will eventually lead to a sentiment to be understood from that particular sentence, right? uh, let's see, finally we have removed the duplicates, right? So I found some of the duplicate, and I guess the reason for this would be the smaller tweets. For example, let's say there's a tweet of Holi, right? So there's a tweet of happy Holi, right? So it's a common tweet, right? So and it does not make sense also. So I've removed the duplicate some. Let's say even if it's an offensive tweet, like some other tweeter there was an offensive tweet, so for that also we want just one tweet, right? We don't want our model to be because if you don't remove the duplicates, your model will be biased towards one particular result, which we don't want. So we dropped the duplicates, and later we applied word tokenize, right? So word tokenize we have imported, right? So what word tokenize do, let's see, so it's a tweet list now. So now each word is created, made into a list, right? So we just have made a list till now of each word, so you can see there's a tweet list. So now each of these words is a tweet list, and it will be easier for us to do a count vectorizer or TF-IDF vectorize over it, right? So this was the cleaning part of the tweet. So if you have any doubts, please post it in the comments. I'll be really excited to answer them. And I don't suppose any doubts till now. The only doubt I think you might be having is some of the libraries that you are not able to find. So just check for the spelling mistakes. That was something that I used to find a lot when I do this, and I am expecting same from you if in case there is any error, right? So once you've done the cleaning part, let's start with the EDA part. Okay, so the first EDA what we do is we try to find the length of a tweet. Okay, what are the general lengths of a tweet? What is a maximum length of a tweet? See, there's a fixed amount of length over Twitter, right? That you have to keep your tweet in this particular length. But let's see, in that particular range, what is the most amount of length, and what will the use of it? See, this will make us understand, because there are some tweets which have a length of 1, or let's say less between 1 or 10, so, and they might not be that offensive or something like that, right? So we have just plotted a bar graph of all the text length in that tweet list, right? So how many elements are there? So what we see here is there are most of our tweet have around 8 to I would say 5 to 13, right? Most of our tweet have around 5 to 12 and 13 words, right? Major tweets, and then there's a low and there's a high spike, little bit spike of between 20 to 25, right? And after, most of our tweet list is less than 30, less than 35, and that's again note here that these are tweet list, right? So you have removed a lot of stop words from it. You have removed a lot of hashtags and many other symbols and signs and emojis from it, right? So though there are text which has less words and more emojis, right? So those kind of emojis, those kind of tweets would have already have been cut short in length, and they would be falling somewhere here, right? So just make a note of this, and let's move forward, right? So what we did, we removed all of those texts which have zero length. And how is this possible? You might be thinking, okay, we have to write something in a tweet, right? So again, remember, this is not tweets, these are tweet list. How did we get tweet list? We got tweet list by removing many words. So it might be possible, so let's say there is a tweet of how are you, and there's a emoji of kind of a person looking curious, right? So how, are, and you, all of these things will be removed in stop words. The question mark icon will be removed in stop words, and the emoji would be removed in stop words. So once you have done the pre-processing, this tweet will completely go, it will not give any sort of sentiment out there, right? So its length would be 0. So what we have done here, we have removed these kind of a tweet which has 0 length, right? Finally, when we see the shape, it's 44,647. I guess initially it was 49 or something. Let's see, yeah, it was 47 647 691. And what do we have right now? We have 44647. So around, I guess, 30 or 40 tweets only have been removed, and let's at least have one words in it. Now I'm making one function to plot a word cloud. So what is a word cloud? Word cloud, it's something like this. You guys might have seen it somewhere. I think I need to run it. So word cloud is something it's an insight that gives you, okay, there, see, I can give you a list of word counts, okay, how many words are, which is the most occurring word, right? Or but in visualization, our point is to make understanding easier, right? So when you visualize a word cloud, a word which has more frequency will have a bigger cloud in it, right? So I made a function and I have to do it for all the categories, right? I'm planning to do it for all particular sentiment, and we have around 6 sentiments, right? So it's better to, like, one thing is I can run this function and again, right? And the plotting function again and again. So if you have to do it again and again, and you're doing it again and again, so there's no point of coding, right? When you're doing actually coding, the purpose is that you do it once and use it again, right? So I have made a function, and now later whenever I have to make a word cloud, so I'll call this function, I'll pass a particular category, and it will make the word cloud for it, right? So what I have done here, I have just filtered out my data, the whole data on that particular particular cyberbullying type, and then I have done just taken a string of it to I guess to make you know the data for word cloud, and then I've import passed all of these things in a word cloud function, right? So see, this word, where this word cloud comes from, we have imported it, right? So if you go above, you will see we have imported word cloud, right? So word cloud is a library that enables you to make these great word clouds. You can pass really good arguments, and you can also pass a background image. Okay, I'll want it in this pattern, right? So you can have Twitter pattern, or kind of a political pattern, anything like that, right? So let me run this function, and then it just matplotlib library to make it, right? I have taken a blank plot, and I'm doing a show. I have defined an axis, and I put a title, right? So these things are not something complex, just have to follow the steps, and these are self-understood things, right? So, and let's say after that, as I said, I have split my data on the 6 sentiment, and I'll be doing a EDA individually to see the trend and kind of a things in it. So first I'm counting a top 20 words, right? So for all the words in the particular category of gender, right? All the tweets which are offensive towards gender or particular category of gender, right? These are the most common word that people see in those particular tweets, right? And these are the words that will help us classify these sentiments. I've taken top 20. You can take to 15 or top 50 or top 50, anything, and it should make sense, right? So yeah, I think it's making sense. These are quite offensive words. Later I'll be making a bar plot of it, right? So which word is more significant, and for similar thing I have made a word cloud of it, right? So see, now it will make sense. For gender, these are the words that make sense, right? So as you see, let's say I have two words of let's say make and joke, right? So joke would be a quite bigger word, and make is a smaller one, right, in the word cloud. So the point, like, this is how you understand the this particular word cloud. Yeah, joke is bigger word, so it has more frequency. Going ahead, similar we did for religion, and we found this also, right? Okay, these are the most when offensive tweets are there, cyberbullying tweets are there, these are the most particular words. So don't be offended by anything like this, because these are offensive tweets, right? So this is the wrong data, right? So that, and we are doing here a good work of classifying the wrong data, right? So there is if you're seeing any tweets there which might actually offend, if any word here which is offensive to you, so just don't feel bad about it. We are doing a good work to classify this work, and that is one reason that we initially discussed why this particular application is really important, right, of cyberbullying tweets, right? And when we are going towards an era of going freedom to speech, right? So there should be a limit of it, right? When you are hurting others, right, there's no freedom when you're hurting others. So let's say and the third one, when we again make a bar graph here, right? So we see that, okay, particular words have more frequency, and those are the reason that they're offensive. And if I plot a word cloud for religion, I'll get a word cloud, and I can again get the same type of things. And similarly I do for age. So what I'm getting, okay, this is for age cyberbullying. So tweets which are towards offensive towards cyberbullying a particular age category, it has more of bullies, schools, high, these kind of word in it. And if I plot a word cloud for better understanding, so it will be something like this. If I go for particular ethnicity, so it will be some racial discrimination words, those out there and in the tweets. And I can see very offensive words here. Black is there, white is there, those are all racial discrimination words, right? So I'm sorry about this. Okay. And again I plot on I plot a word cloud, and you'll get. And finally the other cyberbullying tweets that I have, it's these. Now this is the other data, right? So these are words which are other cyberbullying categories, right? So let's see, it's like bully, like get, idiot, these kind of words. And so see, some of you might think, okay, these words should have gone into one of the other category, but it's labeled data, right? And I guess this labeling would have been done, I don't have a source of it, but like in my experience, it would have been done by two main sources. One would be your manual labeling, labeling, where people sit and classify these tweets as particular category of offensiveness, based on some policies. The other one would be individual feedback, right? For example, you see a tweet somewhere and you feel that, okay, it's cyberbullying, or a person who is facing cyberbullying reports a particular tweet, right? So in that case, the Twitter team classify that particular tweet in the particular category, and this is that data, and we are trying to build a model over it. So if I plot the cloud for cyberbullying, it will be these kind of words. Now these are the terms which are not cyberbullying, right? So you'll see all kind words here, right? See, it will be school, love, no, need, make, people, right? So these are the words which are not counted in cyberbullying, right? So now once I have done this, and this was all my EDA part. So what I have done till now, I have prepared, let's say, see the final DF before we go into a modeling. We have a particular tweet list in our DF. So we had initially all the tweets, right? And in that tweet there were hashtags, there were spaces, there were stop words. We understood what stop words are, and and we had sentiment, right? So we have encoded our sentiment to a number, and we have put all of the text into particular tweet list which has words which are actually making a difference, right? So in tweet list you won't find any word which is kind of a general word. These all words are something that combination of these words can help you identify, okay, this tweet has this word, it's related to a particular ethnicity, or this tweet has this word, is related to a particular religion, and then it will be easier for us to classify that particular tweet into cyberbullying or not. So this was a part one of this video. Going further, what we'll do in the second part, we'll make a model, right? We'll try multiple models, we'll do a cross validation over them, we'll do tuning over them, and finally we'll fit our particular the model that suits best, and we'll find a particular score on that. And once we have that model, our goal would be to save that model in a pickle file, and then use that model to into a front-end application, right? So that's the main goal of this whole 3-part series. So this was the part 1 of this particular video, and do check out the part 2 of the video to see like what model fits the best, and how we can go further in the project. Thank you.